that, then please let me know and write some text here in QQ. I can see that on another display. So back to the third group, the binocular depth cues. There are two. The first one is about eye convergence. And if you see that picture, then I think you know what it is about. So we move our eyeballs. Our eyeballs can rotate a bit, so they can change the angle, so we can focus to different or look at different objects. If they are near to us, like this pinball, then our eyeballs, the lenses, they move inward, both sides, and we can focus to this object that is very near to us. Or if the object is in a large distance, then our eyeballs move in the other direction, and so that we can see this object and focus on that. Maybe you ask yourself, what's the difference between eye convergence and stereoscopic depth? So convergence is just about the simultaneous inward movement of both eyes toward each other. So usually in an effort to maintain single binocular vision when viewing an object. So this is just about the movement of the eyeballs. There are muscles outside these eyeballs, and these muscles move the eyeballs. And because we use these muscles, we get information about the angle, in which direction is the eyeball oriented. So from this information, we get a depth cue. It's a bit different with stereoscopic depth, although it's also related to the movement of the eyeballs. But here it's about the two different images that we get. So our two eyes, in fact, get two slightly different images. And yes, we can simulate that with a stereoscope. So these devices here, this is a very simple stereoscope. This is a more sophisticated one. The only thing these devices are doing is they separate two images. So we have two images, and with this device, these images are separated so that just one eye gets one image. The left eye gets the left image, the right eye gets the right image. And these two images, they are slightly different. Also on the right-hand side, this coast line, these rocks, these photographs are taken from slightly different positions. So it should be like looking at this area one time with the left eye and one time with the right eye. And with the help of the stereoscope, then we can mix these two impressions in our brain and get a three-dimensional impression, like looking at the real world situation, not an image of it. So stereoscopic depth is about these different images that we get. That's the difference to eye convergence. Eye convergence is just about the movement of our eyeballs. So most stereoscopic methods present two offset images. Offset images simply means they are slightly moved from each other. So there's a slight difference between them. And we see those images separate, one for the left and one for the right eye. And this emulates the retinal parallax. Retina, remember retina, this is this kind of surface back in our eyeballs, in the inside of our eyeballs. So there are the sensors, the sensitive areas, the cones, and so on, to where we can see. On the one hand, we can see the colors there. On the other hand, we have this very tiny area, the fovea, where the acuity is greatest, and we see the most details. This is all part of the retina. And the retinal parallax means that we have a slightly different image in the left and in the right eye. This difference between them is called the parallax. Or there are other terms, the retinal disparity or binocular disparity. It just means there is a difference between the two images, a difference between the image in the left eye compared to the image in the right eye. And these images are just two-dimensional. Then they are combined in our brains, and they give us the perception of a 3D depth. So it's like an impression of the real world. And this technique is distinguished from three-dimensional displays that display an image in 3 full dimensions, allowing the observer to increase information about the three-dimensional objects being displayed by head and eye movements. So it's like looking at a model, for example, a city model, where you have physical buildings, three-dimensional buildings that you can look at from different positions. So you can walk around such a model. There is a fantastic model of Wuhan, for example. Maybe you have seen it. You can walk around. So all the buildings are there, the hills are there, the river, everything, and you can see it in 3 dimensions. This is then a physical object. We are talking here about images. So it's the depth Q is an information about the 3rd dimension within a 2-dimensional image. And yes, everyone knows about that. If you look at your thumb, for example, you stretch your arm in front of you and you look at an object, and then you just look with the left eye or with the right eye, then this object jumps. So one time it's maybe right of the thumb, one time it's left of the thumb, depending which eye you use. And it's about this difference. This difference is the parallax. And then these 2 images, like here, you have 2 different images on the left and on the right. And in our brain, they are merged to a 3-dimensional impression of the world. And different methods now have been developed, not only separating 2 images that are slightly different, like the example with the stereoscope, where you can use a stereoscope to look at these 2 images. There are other methods. One is the anaglyph 3D method. So the stereoscopic 3D effect is achieved by means of encoding each eye's image using filters of different, usually chromatically opposite colors, typically red and cyan. I'm sure you have seen that and you've tried that. They are, well known. And sometimes you can use them here for this kind of satellite or remote sensing images, aerial images. Today with the UAVs, the unmanned aerial vehicles like drones, etc., we can take a lot of pictures, and it's also possible to combine pictures that are taken from slightly different positions, for example, and then to get this 3-dimensional impression. But you need of course, these glasses to separate the two images. In fact, there are two images are printed here within one, but in two different colors. And one color blocks the other color, and therefore you see only one. And yes, so the two different images reach our brain. And you can even do this with maps. So you can take a topographic map, and then you can just slightly separate. That means you move or you create a small distance between the two, and then you need, of course, the two colors, and then you can create a three-dimensional impression. There are other methods. The polarization systems. This is another way to present stereoscopic pictures. And here, two images are superimposed onto the same screen through polarizing filters, or presented on a display with polarized filters. So different ways to do it. On most displays, every other row of pixels is polarized for one eye or the other. This is called interlaced. The viewer wears low-cost eyeglasses, which also contain a pair of opposite polarizing filters. As each filter only passes light which is similarly polarized and blocks the opposite polarized light, each eye only sees one of the images. And here you have this functional principle. And these are glasses that are often used in the cinemas. So I guess you have tried that and you have watched a 3D movie with such glasses. There, this technique is quite popular, polarization technique. And then you have a three-dimensional impression. Another technique are shutter systems. While anaglyph 3D and polarization systems are passive technologies, shutter systems are an active technology. This means the glasses play an active part within the system. The image for the left eye is openly presented, while the right eye's view is blocked when the opposite happens. This is repeated so fast that the interruptions do not interfere with the perceived fusion of the two images into a single three-dimensional image. And here you have this functional principle. So in very fast, the images change. So one time you see for the left eye, one time for the right eye, then again for the left, again for the right, and so on. And these glasses are usually a bit bigger. So you see here the thick frames compared to the polarization glasses. And these thicker frames, they conceal electronics and batteries. So there are electronics within these glasses, because they have to, and that's the name, shutter glasses. So one eye shuts and the other is open, and then this is reversed. So this glass has to do something, and therefore it's an active system with its own power source. More funny way. It's not really a technique. It's more back to the basic idea how to present two different images. But it's interesting because you directly see how this works. And these random dot stereograms, RDS. A stereo pair of images of random dots, which when viewed with the aid of a stereoscope or with the eyes focused on a point in front of or behind the images, produces a sensation of depth, with objects appearing to be in front or behind the display level. I will show you an example. One interesting way to use a random dot stereogram is the so-called autostereogram. And auto means self. So the automobile is something that's mobile by itself. So because you don't need your own energy, you have other energy. You have the fuel and the machine working with it, and therefore it's an automobile, self-mobile. And autostereogram means that this works within just one image. So it's a single image stereogram designed to create a visual illusion of a three-dimensional scene from a two-dimensional image. In order to perceive three-dimensional shapes in autostereograms, one must overcome the normally automatic coordination between accommodation, that's about the focus, we talked about that, accommodation is another depth cue, but accommodation is monocular, and horizontal vergence, so this is convergence, this is binocular. Therefore, if you have just one eye, autostereograms do not work. We are still in the binocular section, so this only works with two eyes. And with this graphic that I will show you, you will hopefully see how it works. So there are two ways how to separate the images. As you will see then in the example, you have just one image, but you need to see two. And you have to do something with your eyes then. So these are our eyes. So it's our head, for example, and we are looking at a certain object, and automatically we focus on that object. It's like this is the display. So we focus at the display so we can read the text and we see the images. Now, there are two ways to separate the images. If we can use cross-eye, this is like that you imagine to look at an object that is nearer to you than the display. So you try to focus in front of the display. This would mean that your eyes in the back get two images, separate images. Or you imagine to look at something that is behind your display. Then again, you have two images here. For me, this works better, but it depends. Some people like this method more, others this. I usually use the cross-eyed method. And there is a nice example. I think that one is from Wikipedia. And here you see how this works. It's very, very simple. So first of all, you can create an image. The only criterion is that it's of a suitable size and it contains random dots. Therefore, it's a random dot stereogram. Then you duplicate the image. So these two images, the left and the right, they are identical. This is the first step. Then, the second step, you select a region in one image. For example, this square. This region of the original image. And then, after you have selected that, you simply move it horizontally by a small amount. In this case, it's just one of these pixels. And then It's complete. That's all. Now, so the one this part that you move here, you just move it in the right image. So there's no change in the left image. Therefore, the final version, the two images are not identical, because here there was this slight movement of this square area. And now to view this random dot stereogram, you can use these two techniques, wall-eyed or cross-eyed, till you see the square in a different depth. So you can try now this technique. You should try to get each of these two images separated. So one for each eye. And if you manage to do so, you will see that this square area, it's in front or behind the other level of the whole image. So you see some depth within it. That's the interesting thing. So for me now it's easy, but at the beginning it wasn't. I also had to try relatively long till I managed to see this effect. So this is the whole idea behind it. It's very simple, and you can try that, or maybe you tried already. There are whole books about this with stereograms. This here, it's also an autostereogram. It is has another name as well. It is also called single image random dot stereogram, SIRDS. And there is even a site online that you can use to produce such images if you like it. And there is also explanation and a description how to do it. So it's just the same as with the image we have just seen. The problem here is now you have just one image. And this is the description, what you should do. I will not go into details here. You can try that if you like. It's the same idea. So you need to separate these two images. The problem here is that they are within one image. So it's easier with the example before. But if you manage to see this square in a different level in front of you, then you have already managed to use this technique, this method. So it should then also work here. And you should see something like that. So it's a kind of spiral shape. And this spiral is a bit three-dimensional. So it's not black or gray like here. You still see these colors like here, but there is a three-dimensional effect. And with this three-dimensional effect, based on this depth Q, you see this spiral, if it works for you. There are whole books about this. It's also for kids to play. But for us, it's interesting because we learn something about the depth Qs and how they work. And here is another one. So here you should see a cone. For us, it's also interesting because if you manage to use this method, so this cross-eyed, for example, then you don't need a stereoscope. You can look at these images now with the same technique, and then you will see this landscape in 3 dimensions. So it's just the same with the example before. It's those pixels and this square area that is moved a bit. So here is the same. You can look at these two images, and then you try to move them by looking in front or behind these two images. so that they are somehow, moved over each other, and then you have a three-dimensional impression. I hope it works for you. It's quite nice, and it makes it also easier to remember this depth cube. This is the last slide in this section about the depth cubes. Do you have any questions about this? So important is that you know about these different kinds of depth cubes, how they are named, what is the idea behind them. So why do they work? Why are these different terms here? Why are these depth cubes? I've tried to show you many examples, and I hope I managed to explain it to you in a way that it was easy for you to follow. So there are these three groups, and this random dot stereograms, the anaglyphs, and so on. This is all about the stereoscopic depth, the retinal parallax. So if you understand this term, retinal parallax, then you know what it is about. Just remember, there are two different images that we get. One is on the retina of the left eye, the other is on the retina on the right eye. They are different. Therefore, there is a disparity, and this is called a parallax. While eye convergence is about the muscles that move our eyeballs so that we see an object near or far away. If you have no questions about this section, we have about 13 minutes till it's break time, and I want to show you, or maybe I first send it to you, then you can also look at it on your own device. So I just upload a few sample questions. So the idea is that you should get an impression. How is this final exam organized? How could the questions look like? So I hope it worked. So this is how the exam could look like, but these are just a few sample questions. There will be many more questions then in the final exam. You have to fill in, of course, your student number, your name in Chinese and Pinyin. And then your task is, there are two tasks. The first is multiple choice questions. You should mark the correct text. There are always three possible answers, A, B, or C. And you should mark the right one. And this is a text or a word, a single word or a text, several words that fit into a sentence that is written before. And you will then see the examples, then it's clear what I mean. And so there is a position marked with this question mark. And the text should fit in there. And there's always only one right solution. So instead of this question mark, there should be text or word A, B, or C. And for each correct answer, you get 2 points. For each wrong answer, you get 0 points. This is the main part of the final exam. And then there is a second part. These are open questions. You should fully answer the question in a concise way. Concise way means you should write what is relevant, what's important, and not too much text that is not important or not related to the question. Your score is not influenced by the quality of your English writing, but of course, as long as it is clear what you mean. So if I cannot understand what you are talking about, what you are writing about, then it's of course difficult for me. So be careful to use technical terms appropriately. It helps a lot if you are able to use the right technical terms. It's easier then for you to express yourself. It's easier for me to understand what you mean. And of course, it's also important because you should know about these technical terms. Therefore, you should use them. The highest possible score for the whole exam is 100. And this is a closed book test. So no aids, no devices, or any additional materials are allowed. Of course, no mobile phones, no books, no materials from the lecture. So you have to know everything from your memory. And you will have 90 minutes to answer all the questions. Now, here's the first example. So here is a text missing that you should fill in. Something is a binocular depth Q. And then you have three possible answers. A, depth of focus. B, chromostereopsis. Or C, eye convergence. And maybe you know it already because we just talked about it. The right answer is eye convergence. So then you should mark C. That would be correct. Again, there is just one right solution, and there is always one right solution. The second example, but these are questions you cannot know right now because we haven't talked about this. Another example, there are two main types of cartograms. So the first kind and the second kind, second type are area cartograms. So what is the first type? Point cartograms, line cartograms, or volume cartograms. And the right answer here would be line cartograms, B. Or John Snow's cholera map from 1855 is an early example of visualization methods, thematic mapping, spatial analysis. As you know, there is just one and only one right answer. So sometimes students are confused with such questions because Snow's color map is also an example for a visualization method. It's also an example for thematic mapping. But the question is, which of these is appropriate if it's an early example? There are earlier examples for visualization methods. There are earlier examples for thematic mapping. So the right answer is C. It's an early example of spatial analysis. So there are much older thematic mappings or examples for thematic mapping. Therefore, it's not an early example of thematic mapping, and it's also not an early example of visualization methods. Right answer would be C. Or the useful field of view. We will talk about this this or next week. The UFOV varies with A, target number to adapt to a greater amount of targets in the attended region. B, target size to adapt to a greater overall size of targets in the attended region. Or C, target density to maintain a constant number of targets in the attended region. Of course, you have to think about it. Some of the questions you have to learn, you have to know about it. Some are more about understanding. So here is about the target density, C. But yeah, it's clear that you cannot know that now because we have not talked about it. And the last example, the illusion can influence the estimation of circle sizes. Is it the Ebbinghaus-Titchener illusion, the Müller-Lyer illusion, or the Jastrow illusion? And yeah, you should know about these different kinds of illusions and their names. The Müller-Lyer is about this line, the length of a line with arrowheads. Maybe you remember that one. Jastrow is about this, how it is called, these arcs. There is this example with the railroads for kids. These arcs that look like different lengths, but they have the same. And therefore, only A, Ebbinghaus-Titchener, can be the right answer here. So this is the principle how these questions work. Do you have any question about this? I just check something, a moment. Yes, I just checked. So last term there were 35 multiple choice questions, 35, and 2 open questions. But this might be changed. So this might change. I'm not sure. It depends on how the final exam will look like. But there will be one larger part with multiple choice questions, and then there will be another part with 2 or 1 or 3 open questions. So 1, 2, or 3 depends on the length of these questions or the expected answer to them. So then we have break time. Now it's 5 minutes break. Yes. So you can think about questions. So if you have a question, please write it down here in QQ.